Okay, so today we're going to start with 7.1, which is linear inequalities. In the past, what we've been mostly working with is we've been working with equations. And in equations, we know that we always have something is equal to something. So for example, we could have x plus 5 is equal to 10. Okay, but this is not always the case. We don't always have a quantity being equal to something else. Sometimes we have a situation where we know that it's more or less than that. Okay, so we can have, in the case where we say more than, we can say x plus 5 is greater than 10. Okay, this is more than. Okay, we can also have a situation where we know that x plus 5 is less than 10, and this would be less than. Okay, so these are our options that we can have. We can also say that we have at least 10. X plus 5 is at least 10, which means we have x plus 5 is greater than or equal to 10. So that is at least or greater than or equal to. We can also have x plus 5 is at most 10, which means that we have x plus 5 is less than or equal to 10. And this would mean at most or less than or equal to. And what we're going to be looking at today is how to solve these. These don't actually change at all, really, from linear equations. There's some very small differences, which we'll talk about. We'll do that a little more later on. But to start off with, let's look at one of the ones we've just done. So let's say x plus 5 is greater than 10. Okay, with linear inequalities, it's exactly the same as a linear equation. Okay, so we're just going to say x plus 5, we want to get the x by itself, so we're going to minus 5 from both sides. On the left, we now have x, and on the right, we have 10 minus 5, which is 5. And that one's done. Okay, and you can see that our answer is that x is greater than 5. And what that means is any value higher than 5 will fit this equation. So if we put a 6 in instead of x, it will fit this equation. If we put a 7 in, it will also. If we put 8, fine. If you put 200 in, that will still satisfy this equation of x plus 5 is greater than 10. If you put a number of 5 or below, then it will not satisfy this equation. So if we substitute in 4, 4 plus 5 is 9. 9 is not greater than 10. So that does not satisfy the equation. Okay, now this is a fairly straightforward one. They don't really get too much harder than this. So we can say, for example, 2x minus 3 is less than or equal to 12. Okay, so we know with a linear equation like this, we would firstly add 3 to both sides. We're going to then get 2x is less than or equal to 15. Then the next step is to divide by 2 on both sides. And then we end up with x is less than or equal to 7.5. Okay, so for the most part, this doesn't actually change very much at all beyond this. There are a few exceptions. Okay, so the main exception with inequalities is that if we multiply or divide by a negative number, we need to reverse the symbol. So reverse the inequality symbol. Okay, this is the main rule that changes things from what you'd normally do with a linear equation. So, for example, if we have, let's say that we have 3x plus 6 equals, oh, sorry, not equals, we're not doing equations anymore, is greater than or equal to 6x plus 1. Okay, now let's say that we don't do my normal tactic, which I always like to remove the smaller x. Let's say instead that we want to remove the x's that are on the right. So we're going to minus 6x from both sides here. Okay, on the left, if you do 3x minus 6x, you're going to get minus 3x plus 6 is greater than or equal to 1. Okay, our next step here would be to minus 6 from both sides. So on the left now, we will have minus 3x is greater than or equal to minus 5. Now, at this point, what we need to do to get x by itself is we need to divide by minus 3. And when you do that, you need to take your sign and you need to reverse it. So now what we're going to have is on the left we have x. Our sign now is going to be less than or equal to. Okay, and then we're just going to get 5 divided by 3, which is 1 2/3. Okay, so our solution for this one is x is less than 1 2/3. Less than or equal to, sorry. And we can test this to make sure. So I'll show you now with by substitution how we can make sure this works. So let's pick a number that's greater than 1 2/3. Okay, so a number greater than 1 2/3, let's make it 2. 2 is a nice easy number. So what we're going to do is we're going to substitute that in. Check. We're going to substitute 2 in to see what happens. Theoretically, that's going to give us the wrong answer. So we get 3 times 2 plus 6 is greater than or equal to 6 times 2 plus 1. 3 times 2 is 6, so we're going to get 6 plus 6 is greater than or equal to 6 times 2 is 12 plus 1. 6 plus 6 is 12 is greater than or equal to 13. And we know that this is not true. Okay, so that shows that yes, our answer is not going to be the other way around. It shouldn't be that x is greater than. We did the right thing by reversing. You don't normally need to do this check as long as you follow your rules. This is basically it though. Solving linear inequalities doesn't get any harder than this. So the big thing is making sure that if you multiply or divide by a negative number, that you reverse the inequality symbol.